At 4:36 a.m. local time this morning, the Bulusan volcano in the Philippines unexpectedly erupted, sending a plume of ash multiple kilometers above its summit. However, I only have one video of the actual eruption because it solely took place during the dark since the sun would not rise until 5:24 a.m. However, from this collection of images we can see that an unusually lengthy pyroclastic flow was generated, at least for this volcano, hence the gassing seen from Bulusan's southwestern edifice after the 24-minute-long eruption ended. I have made a preliminary geolocation attempt for this pyroclastic flow, with it seemingly traveling 3 kilometers or 1.86 miles to the west-southwest, stopping 1,400 meters from the closest structure. Ash from this eruption rose into a 6,096 meter or 20,000 foot high eruption plume, which subsequently drifted to the west and west-northwest, causing a trace to 1 millimeter thick of ash to fall on select towns within a 25-kilometer radius. As a result, Bulusan's alert level was raised from 0 to 1 on its 0 to 5 scale. What had just occurred was Bulusan's first eruption since June 2022, and since it did not erupt any lava, it was purely phreatic. Phreatic eruptions are a very common type of volcanic eruption which either occur during the early stages of a larger magmatic eruption or, as is most likely the case with Bulusan's eruption, represents an isolated event or series of events. They are caused by the interaction of underlying magma which lies underneath the volcano with regional groundwater. This magma generates large quantities of heat which is transferred upwards and outwards to surrounding rock. Some of this rock subsequently heats ever-present groundwater, flashing it to steam, and since steam takes up about 1,600 times the volume of the water it once was, it causes an immense amount of pressure to build. Once this pressure becomes sufficient, it breaks through the path of least resistance, which is almost always overlying rock, fracturing that rock into fine ash and generating an explosion via phreatic volcanic eruption. Phreatic eruptions are thus one of the hardest volcanic eruptions to predict, as they can theoretically occur at any volcano with an active hydrothermal system and magma at depth with little or no warning, as was the case with Bulusan. Almost all of Bulusan's eruptions are phreatic, and half of these since 2015 have only involved a single brief explosion. The rest involved multiple explosions that occurred intermittently across time spans of a week to 6 months, meaning that one of these outcomes will probably occur at Bulusan, but we do not know which one. Thus, a 4-kilometer exclusion zone exists in all directions around Bulusan's summit, and an additional 2-kilometer expanded exclusion zone, in other words going from 4 to 6 kilometers away, exists to the southeast. While that latter zone can be entered, Phivolcs advises vigilance since it is at a higher risk of being affected by volcanic hazards than other sectors. Phivolcs also recommends wearing an anti-particulate mask until the ash on the ground clears, as very fine particles, if they get in your lungs, are bad for your health, including an increased risk of lung cancer. While today's eruption column was higher than several other recent eruptions from the same volcano, it seemingly deposited less ash than prior events. Regardless, due to the implied volume of the material in place by the pyroclastic flow, I estimate that around 1.1 million cubic meters of tephra was ejected, meaning this latest eruption will be just barely assigned a Volcanic Explosivity Index of a 2. I can also presume that Bulusan's small summit crater lake was vaporized by the eruption, but this will likely be quickly refilled by subsequent rainfall. For my non-Filipino viewers, you might be wondering why around 70,000 people live in close proximity to what is the nation's third most historically active volcano, and while there are a number of reasons, one key component is the very good farmland. The soil is very nutrient-rich from Bulusan's frequent small-volume eruptions, but there is also a hidden component. You see the giant, suspiciously flat area to the southwest of Bulusan? That actually represents the floor of an ancient 12-kilometer wide caldera that formed an eruption about half as large as Tambora's 1815 eruption, albeit 41,404 years ago. That eruption emplaced dozens of meters thick of nutrient-rich material which will provide great soil for farmland for many subsequent tens of thousands of years. As a final note, I would like to thank my new YouTube channel member Elijah Govardhan for supporting my work.